visible and am I audible?
Yes, sir.
Okay. So let us continue our discussion of assembly language programming. Yesterday we have seen few instructions. Today we will see more instructions and also simulation on HTML Studio. Meanwhile, if you have any doubt, you can unmute your microphone and ask me your doubt, right? Here actually we were talking yesterday that suppose if you want to transfer some immediate value to register R0 and R15, you cannot use LDI because while using the LDI instruction, there is a restriction that you can only use the registers R16 to R31. But it doesn't mean that you cannot transfer any data to R0 to R15. If you want to do that, for example, if you want to load value 10 in a register R0, what you can do here is that you transfer 10 initially to R16 and then give the instruction move R16 to R0. So likewise you will be able to transfer content to any register. You cannot copy immediate value directly into the memory, that is SRAM. But what you have to do, you have to transfer initially your content to some register and then that register you can save. So in this example, the content from memory location 0x2 to 0 is transferred to R30. Content from memory location 0x2 to 1 is transferred to R31. Both is added. Both the locations are added and the result is saved back to the location 0x2 to 1. So this is how you can do. There are more number of addition instructions like we have studied, add RD and RR. So it will be able to add any registers. That means here instead of RD you can use R0 to R31. Instead of RR you can use R0 to R31. So you can specify any register here. So for example here R16 and R17 are specified here. Then addition with carry. So in case of a addition with carry, along with the addition of these two registers, it will also consider the carry flag. If carry flag is set, then it will add one more into the result. If carry flag is resetted, then ADC is same as that of the add. Both is same. But if ADC will consider the carry flag, if carry flag is set, then it will also add the carry flag along with the content of the registers. This is how actually few more instructions are there similar to add. There is a subtraction instruction is there, multiplication instruction is there, and this is a logical instructions. So there are AND, OR, NOT, exclusive OR. These are the logical instructions which we can use with the registers. So these are very few examples. You can add R25 and R9. So when you give this instruction, this means R25 is equal to R25 plus R9. So your arithmetic and logical unit will be useful in performing such arithmetic operations. Add R17, R30. So R17 and R30 will be added and the result will be saved back. The result of addition will be saved back to the R17. So these all are assembly language instructions and it's very easy for human being to understand these instructions. But as I told you that it is very difficult for a computer to understand this. So we require AVR Studio. So it is using assembler. It will assemble these instructions and it will produce a hex code out of it, and that hex code it can understand. Right. So hex code is basically it's a sequence of binary ones and zeros, and our microcontroller and processor can understand ones and zeros. It cannot understand the hex code directly. Okay, now this is a very simple exercise for all of you. Just take notebook and pen and try to write instruction for this. We want to calculate 19 plus 95. So I request all of you to take a notebook and pen and try to write a small program for this exercise. So I am giving you some time here. I will stop for a moment. Meanwhile, you can do the exercise, and then I will tell you the answer so that you will be able to verify the answer with you. So programming is just like a swimming. To learn the programming, you have to do programming. If you do not do the programming, then simple lecturing will not help you. It is something like, if you want to learn swimming, then you have to swim. If you read the book on swimming, if I give lecture on swimming, then it is not possible for you to do the swimming. So swimming actually requires exercise. Similarly, programming also requires exercise. Yes, you have to do programming yourself, and it may be wrong initially. Initial instructions may be wrong, but don't worry, you can later on correct it. So whatever the wrong instructions are there, and you will find that it is wrong, so you will write the right instructions later on, and that's why recursively you will learn a lot, right? So programming you have to do. So whenever you sit for a lecture, you please keep a notebook and pen with you, so that along with me you can also do the exercise. Okay. I hope all of you must have started doing this exercise. This is the answer I am displaying here. We want to calculate 19 plus 95. That means we have to shift this value to some register. So LDI R16, 19. So 19 is transferred to R16. 95 is transferred to R20. So both are transferred to some registers. And then finally both the registers are added together. So add R16, R20. So it will calculate the result 19 plus 95. The result will be saved back into this register R16. If you have any doubt in this example, you can ask me.
સર મલ્ટીપ્લિકેશનમાં યા એડની જગ્યાએ ખાલી એમયુએલ એમ જ લખવાનું ને ખાલી
પરફેક્ટ બરાબર છે. એડની જગ્યાએ એમયુએલ લખવાનું, રાઈટ. પછી આ રજિસ્ટર અહીંયા મેં R16 લીધો છે, R20 લીધો છે, એ તમે કોઈ પણ લઈ શકો. તમે ધારો કે એક્સરસાઇઝ સોલ્વ કરી હોય તો એ વખતે તમે R16 R17 લીધા હોય તો ચાલે, 18 19 લીધા હોય તો એ ચાલે, 20 21 લીધા હોય તો એ ચાલે. રજિસ્ટર કોઈ પણ લઈ શકો, કારણ કે ટેમ્પરરી તમારા વેલ્યુ સ્ટોર કરવા માટે આપણે રજિસ્ટર લીધો છે. 19 છે મેં R16માં નાખ્યા છે. તમે તમારા એક્ઝામ્પલમાં R16ની જગ્યાએ R21 લઈ શકો, કોઈ પણ રજિસ્ટર લઈ શકો. Temporarily we are using this register to store these values, and then we add both the registers. Okay, now try to calculate this 19 plus 95 plus 5. Try to write a simple program for this operation. If you have done that exercise, I will show you the answer.
સર આમાં એક આઈને 3 નું નહીં થાય ને બે બીટ નું જ કરવું પડે ને આવી રીતના.
Yes, that's you are right. So initially you have to use two registers, add both, and then after you use one more register. So you have to do it like that only. And please note here that in while doing the second addition, I am using intentionally ADC. During the first addition, I don't require to use ADC, because during the first addition we can assume that carry flag is reset. And initially we don't want to consider the carry flag, right? So in the first addition I have used simple add, but in later on it may happen that if these two values will be such that it is generating a carry, then that carry should be considered for the third addition. So because of that, actually for this later on, for this addition process I am using the intentionally addition with carry flag. So it will add R16 was the previous addition, then R21, and then also it will consider the carry flag. Okay. Then it is also possible that we have a few addition instructions with register pairs. So previous addition was only for one register. It was not for pair, so it was basically 8-bit addition. If you want a 16-bit addition, then you can use add IW. Add IW is the instruction in which it will take the register pair RD plus 1 and RD. That means if I write it in this way, add IW R25 R24, so it will take these two registers as a pair. And all of you know that one register is a 8-bit register, so two register means 16-bit register. In that register pair, 8 value will be added into that. So it is basically using the register pair. Right? Similarly, you can use register pair like R25 R24, R27 R26, R29 R28, or R31 R30. So this add IW is available only for upper 4 register pair. That means it is not available for R0, R1, R2, R3, R4, R5, R16, R17 and all that, but it is only available from R24 to R31. Because all of you must be knowing that these pairs are sometimes used as a memory pointer, and sometimes if you want to increment the memory pointer, then this type of instructions are very much useful to us. So it is a addition with a register pair. Then there are subtraction instructions, very much similar to your addition. Instead of ADD you have to write SUB, then it will perform the subtraction operation. So what it will do, it will perform RD minus RR, and the result will be saved back into the RD. So in this case, we are transferring 50 to R16, 40 to R17, and then R17 we are transferring to R16. So result is saved back to the R16. Let us execute this simple program in AVR Studio so that you will get exact idea about how it is working actually. Let me open this AVR Studio. I will open the test program which we have created during our last lecture. So in this example we have seen that I will put the start label here so that whatever we write will be executed only once. So here I have written the add instructions. After that I will write the SUB instruction, subtract instruction. I will perform the same thing, R16, R17, and this increment is not required as of now. Let me compile this project again. So I will build the solution. So it will convert this assembly language into hex code. When succeeded message is coming here, it shows that there are no syntax errors. So is my AVR Studio screen visible to all of you?
Yes, sir.
Okay, I will debug this program. So I will press the F11. I can press F11 to run the program in a single stepping mode. So if I press F11, the first instruction will be executed. 55 will transfer to R16. If I press again F11, 44 will transfer to R17, which you can see here. The registers are visible here, R16 55, R17 44. So whatever the current execution, current writing is there, that will be displayed with the red font. That's why 44 is with the red font. Now I am adding both R16 and R17. So the result is becoming 99. So result is saved back into the 99. Now what I am doing, I am subtracting back again 44. So now result should become again 55. So when we execute the subtraction instruction, the result is again 55. Let me do some modification here. Instead of this, I will say set SEC. SEC means it will set the carry flag. And now instead of add, I am writing here ADC, and let's see what is happening. ADC. So it will add with a carry. Again I will build the solution. After building the solution, again I will run it in a single stepping mode. 55, 44. Now you can see instead of 99 it is a 9A, because carry flag we have set with help of this instruction. So carry flag is also added with the result. Now we use SUB, and when we do that, what will happen? Instead of 55, now it is 56, because carry flag was added previously, right? So that's why here you will see the effect of carry flag. Okay, let me go back to my presentation again. So this is how SUB will work. SBC means it will consider the borrow along with the subtraction. If there is some borrow of previous addition, you can consider it, right? The borrow is a similar concept which you are using during the subtraction process. These are few more examples. During the subtraction process also, this ALU is being utilized. So in this case, R25 minus R9 will be performed and result will be saved back to the R25. In this case, R17 minus R30 will be performed and result will be saved back to the R17. So as you can see here, that all arithmetic and logical operations you can perform with the any registers. In 8085, Parmar sir will describe that you can perform only arithmetic operation with the accumulator. There is accumulator 8-bit register is there in 8085. So all the arithmetic and logical operations you can only perform with the accumulator. Here you can perform arithmetic and logical operations with any of the registers. So that is the biggest difference. Then similar to register pair addition, there is a register pair subtraction also possible. As you can see here, SUBI. SUBI means subtract with a register pair. So in this case, if you write here, for example, SUBI R22 and then $10, then what it will do, it will subtract 10 immediately from the register, but with borrow, because the B is written here, right? Then SBCI, if you write C, subtract immediately with carry. That carry means in the sense it is a borrow basically, because for a microprocessor, borrow and carry both will affect the carry flag, right? And similarly, you can perform the subtraction with register pair also. So in this case, let's say if you take register pair R25 and R24, then 1 will be subtracted from it, right? So similar to addition, you can also use a register pair with a subtraction, right? So subtraction immediately is also available along with the subtraction of different registers. There are few more instructions. One is a decrement RD. So in a decrement RD, the register value will be decremented. So whenever you perform this operation, decrement RD, the whatever the value of register is there, it will be decremented. Increment RD means it will increment the content of the register. Let's do the demonstration of these two instructions in AVR Studio. I will modify this program. I will write it here. So what I will do here, I will increment R16 and I will decrement R17, and let's see what is happening after execution of all these instructions. So I will build this program again so that whatever modification I have done, it will be implemented. Let's run this program. Initial values after execution of all this instruction is 56 and 44. Now whenever I will increment the R16, it becomes 57. And whenever I am decreasing this R17, the R70 at present is 44. This 44 will reduce. Right? This 44 value will become 43. And next time whenever in the same loop if I increase R16, it will become 58, this will become 42, and so on. So this loop will continuously increment R16 and decrement R17. So this will happen. So this increment and decrement instructions are also available. So this will be very much useful while doing the assembly language programming. Let me go back to my slide. Okay. So is it clear to all, decrement and increment operations? If you have any doubt, you can ask.
Yes, sir, clear.
It's clear. Okay. Then let us write a simple program in which we are trying to increment the content of memory location 0x400. That means we have some data at some memory location 0x400 and we want to increment the content at that particular memory location. So let us discuss that program. So first of all, you cannot directly increment the content at memory location. So what you have to do, you have to transfer that data to some register. So in this case, we are trying to transfer the content from the memory location 0x400 to register R16. So we are transferring the content to R16. Then we increment the R16. Ultimately, we want to increment the content of memory location 0x400, but there are no such instructions directly available. So because of that, we have to initially transfer value to R16, increment R16, and then incremented value of R16 we will save back to the memory location 0x400. To save the register value, there is an instruction called STS, store. LDS means load. Load instruction will load data from memory to register. Store instruction will save content of register to the memory location. Right? So this is how you can write a program for a memory location. As somebody told that if you want to do the multiplication, you have to write MUL, right? Multiplication instead of addition or subtraction. Sometimes if you want to perform the multiplication, you can write the instruction MUL. MUL followed by two registers, RD and RR. Here also RD and RR can be any registers from